Hey everyone. So if you've ever built a retrieval-augmented generation pipeline, a RAG pipeline, you've probably hit that wall where you wonder, how can I make this thing faster and cheaper? Well, today we're going to break down exactly how to do that. And the solution? It is way simpler than you might think. All right, let's just dive right in. We've got to start by talking about the core problem with RAG. And look, if you've built one of these, you have definitely felt this pain before. I absolutely love this quote. It just hits the nail on the head, right? Embeddings are the hidden tax of AI. It's like every single time you process some text, you're paying this little invisible fee, this tax that just keeps adding up, both in time and in dollars. So, where does this tax actually come from? And that leads us to the big question, the one everybody asks. Why is my RAG pipeline so slow and so expensive? You've built this incredible tool, but it's just dragging. And those API bills, they keep going up. The funny thing is, the answer is actually pretty straightforward. And there it is. That's the culprit. Every single time you hit run on your pipeline, you are probably paying to process the exact same documents all over again. Think about it. It's like having to read an entire encyclopedia from page 1 every single time you have a new question. It makes no sense. It's super inefficient, and you guessed it, really expensive. Okay, so to figure out the fix, we need to do a super quick refresh on how a standard RAG pipeline actually works. Let's just break down the moving parts real quick. So here's the classic RAG flow, right? You start with your documents, then step 2, and this is the big one we're going to focus on, you turn those documents into embeddings, which are just numerical representations. After that, you retrieve the best document for your query, feed that one document to the LLM, and boom, you get an answer. But here's the kicker. That super expensive embedding part, it happens for everything, right? At the beginning, before you've even asked your first question. Right. So let's zoom in on that critical, expensive step, the embeddings. This is really where all the magic happens, but it's also where all the money goes.
So what in the world is an embedding, anyway? Honestly, it's just a long list of numbers, a vector. But here's the cool part. That list of numbers actually captures the meaning, the whole vibe of a piece of text. You turn your documents into these vectors, you turn your question into a vector, and then the computer can just compare the numbers.
So, for example, you've got a simple sentence like this one, and the embedding model crunches it down into this, a vector, a list of numbers. And these numbers aren't random at all. They're like a mathematical fingerprint of what that sentence actually means. And check this out. This is how it all comes together. We ask, who created Python? The system turns that question into its own vector. Then, using some math called cosine similarity, it compares our question vector to all the document vectors. And look at the scores. The sentence about Python is basically a perfect match, 0.998. The one about the snake, a total mismatch, way down at negative 0.754. So the system knows exactly which document to grab.
Okay, so we've nailed down the problem. We're wasting a ton of time and money recreating these embeddings over and over. So now for the fix. And trust me, it's beautifully simple.
The solution is caching. That's it. All we're going to do is save the embeddings we've already made. You can just stick them in a simple Python dictionary right on your local machine. So the next time the system sees a document it's seen before, it doesn't have to call that pricey API. It just says, oh, I've got this one, and pulls it from the cache. And the difference this makes is, well, it's just wild. Look at this. The very first time you run it, that's a cold cache. It takes about 1.37 seconds per document to generate that embedding. But every single time after that, with a warm cache, the time drops to basically 0. It's instantaneous. What does that look like in practice? A 436 times speedup when you rerun your pipeline. Suddenly, that embedding tax we talked about, it's gone. You just stop paying it for any document you've already seen. But wait, it gets even crazier, because you can cache the query embeddings too. If someone asks the same question twice, you get a speedup of over 15,000 times. I mean, come on, that is a total game changer. So what does our pipeline look like now with this little superpower added? Let's check out the new and improved workflow. Here it is. See that new box? The cache, wedged right in there. It's so simple. Now, before we bother the expensive embedding model, we just take a quick peek in the cache. Hey, have we seen this document before? If the answer is yes, we just grab the embedding and completely bypass that API call. It looks like a tiny change, but that one little step is where all the massive savings in time and money come from. All right, so let's boil this all down. What are the main things you absolutely need to walk away with today? First, remember you're dealing with two different models here. You've got the embedding model, whose only job is to help you find the right document. Then you've got the big LLM, and its job is to read the text of that document and give you an answer. Super important. The LLM never even sees the embedding vector itself. Of course, the biggest takeaway is that caching is your secret weapon. It stops you from making the same expensive API calls again and again. And lastly, let's not forget why this whole thing is so powerful in the first place. It's because these semantic vectors are smart. They find stuff based on its actual meaning, its concept, not just by looking for keywords. And that really brings us to the final, most important piece of advice. Before you go building some crazy, complex solution, just profile your code. Find out where it's actually slow. Because, as we saw today, you might just find that the simplest fix, that little humble cache, is the real hero of the story.